Now let's talk about positronium, and this positronium is it may be the lightest hydrogen-like atom. And and what is this positronium is? Basically, it consists of an electron and have an electron and a positron. So we have positron and we have electron. And and what they are doing is that they are orbiting about their common center of mass. So let me assume this is the center of mass for the system of this electron and positron. And it's a bound system, and it is bounded by electromagnetic interaction. Electromagnetic interaction. Now, this positronium, it's unstable, and the two particles that we have here as electron and positron, they are forming they are forming this system. It annihilates. They annihilate each other to form gamma ray photons, to form two gamma ray photons, or the rays, depending on the relative spin of these particles, this electron and positron. Now, the ground state of this positronium has two possible configurations, and these configurations depend on the relative orientation of electron and positron. So the orientation in terms of their spin motion. Now, the magnitude of total spin angular momentum of a system of two particles, which is electron and positron. So here we have positron, and here we have electron. And if we have to write down the total spin angular momentum, so that will be S, and that's going to be under root of S times S plus 1, and then we will have H bar. And this S can be S1 plus S2, or it can be S1 minus S2, depending on the orientation of the S spins. And if we add the two spins, we will have 1 by 2 plus 1 by 2. And in this case, we will have 1 by 2 minus 1 by 2. And here we will have 1, and here we will have 0. So if we take the component of this S along z-axis, now along z-axis, if we take its component along z-axis, we know that this Sz is simply ms h bar. And this ms that we have here, it takes the values from plus s to minus s, differing by 1. And let's take the case when this s is equal to 0. Now, if I take when s is 0, what does that mean? The spin of this, what we have a system of electron and positron. And positron, what we call as positronium. And now when this S is equal to 0, the spins of the electron and the positron, they are antiparallel. And we can show them like this. So in this case, I have an arrow down, and for another case, I have the arrow up. So this is my S1 equals half, and this is my S2 equals half. Okay, so the two spins are antiparallel. Now the value of ms that we have, what we have Sz is ms h bar. So value of ms for this category is 0. So here ms that we have is 0. And now the state that corresponds to this, s is equal to 0 and ms is equal to 0. This state is called as singlet state. So this singlet state can be written as 1s0 of the positronium. So we have written down here the singlet state of this positronium. That is 1s That's 1 as 0. Now this state of the positronium, this is also known as para-positronium. Para-positronium. Now, the mean life of this para-positronium is it's nearly 1.25 times 10 to the power of minus 10 seconds. And we can write down this as simply 125 times 10 to the power of 12 seconds. So this is 125 picoseconds. This is the mean life of this para-positronium, which is nearly 125 picoseconds. And what it does, it decays into two photons. It decays into two photons or even numbers of the photons. That's the important point here. So if I have an electron and I have a positron, I'm going to get two photons here, okay? Now, in general, for this para-positronium, what we will have simply n times gamma ray photons, where this n has to be even. So this n has to be 2, 4, 6, and so on and so forth. Now, talking about another state, what we have is when this s is equal to 1. Now, when this s is equal to 1, the spin of electron and positron, they are parallel. And so in this case, what we have parallel situation. We have a situation like this. So what we have S is 1 by 2. S2, S1 is 1 by 2. They are in the same direction, and we have S here. So what we have here is that if S is equal to 1, for this, what will be MS? This MS is going to be -1, 0, and +1. Now, the state that's corresponding to this S is equal to 1 and MS is equal to -1, 0, and +1, this state is called as triplet state. This is the triplet state of positronium. This is called a triplet state of positronium, and it can be symbolized as 3s1. Now, this state of positronium is also known as orthopositronium. And the mean life of this orthopositronium is nearly, if I take tau as mean life, it is nearly 1.42 times 10 to the power of -7 seconds. So we can approximate it simply 142 times 10 to the power of -9 seconds. So this is 142 nanoseconds. And what happens in this case is that this orthopositronium, it decays into 3 gamma ray photons, or we should say it has a probability of decaying into odd number of gamma ray photons. So if I take E negative, E positive, what we'll have is gamma, gamma, and gamma. And in general, in this case, what we will have is for this orthopositronium, what we will have n times gamma ray photons. But what is essential here is that this n should be 3, 5, 7. They should be odd numbers.